Sources of energy. Lecture number 1. So this one is actually a very interesting topic, and now let us start with the introductory part of this lecture. So in this particular lecture, we will be basically dealing with the uses of energy, then the conventional source of energy, and we'll be partly discussing about the non-conventional sources of energy. Okay. So let's start with the work and energy concept. Before knowing what energy is, we shall actually know about what work is. So let's start with work. So when a force F is applied on a body, and if the force displaces the body by S units, then we say W amount of work has been performed on the body. Okay, I hope that is clear. So let me show you an illustration. If you have a body at some initial position, okay, consider this blue box as a body, and I apply a force F to it. So this initial position of the body is now changed to its final position, and the displacement is given by S. So mathematically, I define this as the work done, which is written as W equal to F into S. Okay, I hope this one is clear. So mathematically, W is the product, or work is the product of the force and the displacement. Okay, so work is a product of force and displacement. Now coming to the units of work, the units of force is Newton, and the units of displacement is meter. Hence the unit of work is Newton into meter. And this one is also represented by N-M. Okay, N-M. It's not a minus. Now let's learn about energy. So coming to the definition of energy, it is defined as the ability to do work. In a physical sense, energy is the rate of work done. Hence, energy is the amount of work done per unit time to get the work done. So coming to the mathematical aspect of energy, I would say that energy would be the work divided by the time. Okay? Note that the time must be in seconds. Hence, we simply write it as E equal to W divided by T. Okay? Now, let's define the units of energy. Since the unit of work is Newton meter, as we have seen ago, and the unit of time is seconds, hence the unit of energy will be Newton meter divided by second, or Newton meter per second, okay, in words. Another important thing is the unit of energy is also called as a joule, and it is denoted by a capital J alphabet. Now, let's study about the sources of energy. Okay, so as the name suggests, it is the various number of ways in which we can receive energy. So some of the famous sources of energy are the sun, the wind, similarly water, and there are many more actually. These are just to list few. So, what is a good source of energy? I mean, when do you call a source as a good source? Obviously, a source which is free and non-existent is good for us. So, some of the characteristics of a good source of energy are: it should be free of cost, it should be highly efficient, The third one would be the ease of accessibility and availability. It should be easily available to us, and it should be easy to store and transport it from one place to another. So if a source satisfies all these criteria, we can consider it to be a good source of energy. So for example, if I have a solar heater, it gives us hot water without much burden on our pockets. I mean, it gives us hot water free of cost. What it basically does is it uses the light energy from the sun to convert it into electrical energy to heat the water in the vessel. And given below is a photo of how a solar heater looks. I think you must all be familiar with it. Now, let us learn about the other sources of energy. Fine. Some of the other obvious sources of energy are the muscular energy for carrying out physical work by our body, the electrical energy for running various appliances like the AC, chemical energy for cooking food or running a vehicle. These all are some of the other source of energy, right? So, there are basically two types of energy sources. The first one is a conventional source of energy, and the second one is a non-conventional source of energy. Now, let's discuss about the conventional source of energy. So, let's start with the conventional sources of energy. The conventional source of energy are generally non-renewable. Okay? These are being extensively used that these sources might get depleted. So some of the most common conventional sources of energy are coal, petroleum, electricity, oil and natural gas. These are all non-renewable. Please note that. Okay? And these are being depleted. Now the distributional chart of the need of various energy sources in our nation is as follows. This is purely for statistical purpose. You need not worry much about this. Okay? So major part of our nation uses coal. Okay? Now coming to fossil fuels and thermal power plant, hydropower plant, biofuels, etc. These are all few conventional sources of energy. Okay? Now let's learn something about a fossil fuel. In ancient times, wood was most commonly used. The exploitation of coal as a source of energy made the Industrial Revolution possible, right? But as years and years passed, these resources become limited, right? And as these are non-renewable, they had much problem. They had other disadvantages too, like the pollution caused by burning fossil fuels. It increases the number of poisonous gases in the atmosphere. So these aren't that dependable. Now let's study about the thermal power plant. Here basically we'll be using steam and we apply a very high pressure to the steam, and then with this high pressure the steam is made to rotate the motor. Then with the help of a dynamo we generate electricity. Okay, this is a basic principle followed in any thermal power plant. This part is only for your understanding. Fine. So on the similar lines we'll be explaining about the working of a hydropower plant. In this case we'll be using huge amounts of water. These collected water will be sent to the generator with the help of a pump. Okay, and after that this high pressure water will help in rotating the generator's turbine. Now, this generator turbine on rotation will produce electrical energy and we'll be finally getting the electricity. So this is how electricity is being developed in a hydropower plant. Now, similarly, let's learn about a biofuel or a bioplant. In this scenario, we'll be using slurry and oil, and this slurry and soil are then mixed with manure and some fertilizers. Okay, so it's a basic combination of all the bio stuff. Then this mixture is collected in a gas tank, fine, and this gas is used to generate something called as a biogas, which is a biofuel again. There are few machines which run on biogas, but they aren't that much popular because of the lower efficiency. Now let us study about the wind energy briefly. So in this case, what happens is you have a well flowing wind. This flow of wind will help in rotating the generator of a windmill, and as the turbine rotates, you will be generating electric energy. Fine. Did you observe one thing? In each of the case, we are generating only electric energy. But why are we generating only electric energy? Any idea? So to know that, you have to wait for the next lecture. So thank you for watching.